Fine. So we were talking about the decision boundaries. So you have seen that if the data is in a two-dimensional coordinate system, coordinate plane, then you can have a decision boundary as a line on or a curve. If the data is in the three-dimensional space, you can have some planes if the data is linearly separable. And then otherwise you can visualize that you can have a kind of curved surface which is discriminating between the two sets of samples. So the decision boundary may be a line, a polynomial curve, or a surface. We represent decision boundary as a hypothesis, h theta x, or we can say hwx, whichever best way we can represent, where theta is representing the parameters describing the particular decision boundary. Which were the parameters for linear regression? Can you recall? Yeah. So the parameters were slope and the intercept. These were the parameters defining a line in a two-dimensional space, which we also call as MNC. Had this been a line in three-dimensional space, how many such parameters would you require? You may require more than two, that is three. Three values would be there for describing the line, right? Some intercepts with respect to x-axis, some intercepts with respect to y-axis. So three features would be required, three parameters would be required to describe a line in three-dimensional space. So we do not have to calculate those parameters. We have to think of a strategy, think of a algorithm through which the system is capable of estimating those parameters from the data which is given as a training data. Once it is able to calculate those parameters, it has built its own decision boundary. That is what we say that the classifier has learned from the data, from the training data. This is where we are inculcating the learning ability in the system, right? We will see how from the training data the system learns to define its own decision boundary. So suppose we take some non-phase data, if you are classifying for detecting the face images as you have in the Facebook or several other kinds of social portals where you upload your photographs in a group and it is able to capture those segments of the image which describe a human face, right? Have you seen this? So human face is detected and separated out from other portions of the photograph where it is a non-phase data. Let us say we have some background, sky, or some background features which are describing some objects. Let us say there were three objects. Yeah. I'll come back to your question, Naveen. So let us say there were three different attributes that were able to define certain things as non-phase data, right? And there were three different classes of non-phase data. They were linearly separable as we saw in the previous example. Then now we have a phase data for three persons which we are representing by three different colors. What are different distinct points? These are the distinct face images of the persons. So if there are 30 points, that means there are 30 face images, right? Which we have captured through some pre-processing module. We have understood how to best describe those face images and we have plotted them here in the three-dimensional space. Now, what will be the decision boundary? It will be very, very complicated. It will not be as linear as we were seeing in the previous example. So what will you do? You will try to check out with all samples and try to see that the boundaries have all such points included within their zone. Okay. So the question, what does X and Z axis represent in this image? See, all the three axes, X, Y, and Z in this particular picture are representing the three important attributes which are very, very informative about the human face, and they are also distinctive to some extent, not thoroughly. Maybe you took something like, chin shape, but it is confusing, and that is where the people are actually lying in the three-dimensional space very close. Maybe the chin shape is not a very good feature to use for classification. But if it is used, then also we have some kind of similarity among the patterns of one person. That is why they are clustering together. Now it is the classifier's responsibility to be able to define a decision boundary that separates the samples from different classes. And now here you can see that you can't draw a single line or single plane that can separate the samples. This is where comes the non-linear decision boundary in picture, right? So I'm coming back to your question, what is the technique to identify regression or classification? So it is actually the problem in hand that tells you whether you have to use regression or whether you have to use classification. It is not the system which is going to identify regression or classification, fine? We should have certain values of X and we should have certain real or integer values of Y. If these are the, kind of values which you have to predict, then it is regression problem. If it is the class, then it is a classification problem. It is as simple as this, that you should know what to apply, right? Problem should be handled by humans, right? Yeah, so 4 features, we need to plot it in 4-dimensional space, which is extremely difficult, and most of the software packages which are providing you a lot of graphics facility also do not have a way to express it in 4 dimension, though they can do it and they can show you three dimensions in one spot, right? So one instance they can show you X, Y, Z, another instance they can show you Y, Z, and P, some kind of different plots. But to be very frank, we actually do not require to plot these points even if we have 3-dimensional data or we have 20-dimensional data. It is actually the internal mathematics which takes care of all these points and tries to build a decision boundary. It is for the visualization of the students we can see that these points are plotted. Got my point? So we do not require to plot them when we do the actual computation, right? Now let us look at this point. Here it is so much cluttered. If you will download that ORL phase data, you will see that if you plot all 40 persons classes, all 40 persons features in 3-dimensional space, they will be as cluttered as this. And your system will not at all be able to design any specific boundary for each person's face images. And this is a very, very hard situation for the machine learning expert to be able to decide on which features should be plotted or which features should be considered for classification. Of course, when you will go ahead with more discussion, you will understand that anything which is not separable even in 2-dimensional space is separable in 3-dimensional space. Try to look at your own, 2 hands. If you join it like this, they are not separable. But if you remove the 2 hands in the 3rd dimension, they are separable. So anything which is not separable in 3-dimensional space may be separable in 20-dimensional space. And then you have to see how best the features are described so that they are at least separable. But in real world scenario, still that is difficult. You can separate them to higher dimensional space, maybe by taking 40 such distinct informative features. Still you will have some kind of cluttering together of those samples. And then the challenges lie in things like feature selection, feature extraction, of course, the first, feature selection, as well as the non-linear boundary creation. These give you a lot of challenge in machine learning as the machine learning expert, so that your system can learn on its own. Okay? Any questions? Fine. So then we talk about discriminant functions. They represent the decision boundary, and discriminant functions are obtained by taking a linear function of the input vector, the feature vector, and you represent this yx as the weighted sum. Basically, this is the equivalent of y equals mx plus c. If you visualize this as a problem in d-dimensional space, try to, view it as a problem in two-dimensional space. So then you would say that y equals w0 plus w1x. So basically this w0 is the c, the intercept, and w1 is the slope. So it is only a kind of extended form of the line equation that we saw for two-dimensional space. Here this will be in multi-dimensional, d-dimensional space. So this is the equation of line. How does this behave as a decision boundary that you have to visualize? See, now we are talking about this line to be acting as the separator. In the previous classes, we talked about this line as a regressor, where it was trying to approximate the points. Now it has to not approximate. It is actually a kind of reverse action. Here this line has to separate those points farthest, right? Suppose this is there. These are the 3 points in one class and these are the 3 points in another class. They are linearly separable. I have tried to take 2 features. 1 and 2, this particular point is lying in class 1. 1 is lying in class 1, 2 1 is lying in class 1. Likewise, the other 3 points. So you can view a decision boundary as a line separating these 2 classes. The equation of the line is x2 equals minus x1 plus 1, right? You can take this or plus 4. So I am not using y deliberately, as we use y to represent the class label, which is the output. So I will use y as class 1, or I will take y as equal to class 2. Right, so that is why I have not used here y in the equation of line. Okay. So should it be the correct line as a separator? Or is it the parallel line from parallel line passing through x equals to the intercept 1? This is not the correct line. I should have taken x2 equals x1, sorry, minus x1, okay, plus what should be the correct intercept? Somebody can suggest? 4. So the correct intercept is 4. Because we are able to visualize. It is actually the human intelligence that we are using. Of course, the machine will have its own algorithm later on to find out its features. We talked about minimization of some error, right? So how the equation is obtained? See here, you know that the slope of the line is equal to how many, what is the angle of this line from x-axis? You can always write it as tan theta. So if I am writing it as tan theta, what should be theta? Deepika? Is it 45 from x-axis? So we are taking this angle right from this side. It is actually this angle, starting with the x, not from the other side. So it is tan 135. Yeah, correct. So it is tan 135. You have already studied in your high school that this thing is equal to minus tan 45. You remember this? And this minus tan 45 is actually minus 1. So now the slope m is equal to minus 1. And here you can see that this line is cutting y-axis at y equals 4. Right? So x2 is representing vertical axis. Definitely it is right. x2 is representing the vertical y-axis, but I am not taking y particularly to represent y as label. Right? So because now we will be handling data in multidimensional spaces, definitely we will not be having sufficient description of x and y. Otherwise, we will have to take x1, x2, x3, etc. to represent those axes. Fine. So, if you are taking y equals 4, then intercept is 4. You can always write it as c equals 4. And then you can always construct this equation as x2, which is actually a different variable name I am using in place of y. So I am taking, instead of y, I am taking x2 representing the vertical axis equals mx1 plus c. So this comes out to be like this, that I am having x2 equals minus x1 after replacing this m value by minus 1 plus 4. Right. So I have used this 1 erroneously. Why? Because then this is not the correct separator between the two classes. Right? Are you getting? So how is 135 and 45? So 135 is from the positive side of x-axis. That is why we are taking 135. Otherwise, you just take a line to be of 45-degree angle, right, from x-axis. Then you will get the line as this. Are you getting this? Yeah. Naveen, is the difference between 135 and 45-degree angle clear? Had you taken this line to be of 45-degree angle with the x-axis, this could have been actually the perpendicular line. Now we are taking 135 because now it is from the positive direction of x1. Okay. So classes on the graph should be on equidistance from the line. So there is one question from Rajan, whether it should be from the equidistance. Again, it is a question of optimization. So if you want to see that your decision boundary should have been at equidistant, probably SVM, support vector machine, would have been the solution. But here I could be happy with this line or the one which goes in between, or even somewhere a line which just discriminates between the two classes. That should be the decision boundary for us. Yes, slope can also be calculated by simple y2 minus y1 divided by x2 minus x1. That is what Chirag has suggested here. So because you are able to visualize that your points on the x1 axis are 4, 0, and you are able to visualize that your y-axis points are 0, 4, definitely you can find your slope of the line as y2 minus y1. Okay, this should be within brackets and divided by x2 minus x1, right? So this is also one way to see that this line is done. But this is what we are doing as humans. While later on, Your system has to find out this slope. It doesn't have its own eyes. We have to make it, we have to give it a brain. So, what could be the conditions to see whether the lines to be drawn based on x-axis or y-axis? I'm not getting this question. Uh, can you explain, RK? What is the full name? Yeah, Radhakrishna, can you please explain this question? X or Y? You have any confusion between X and Y or X1, X2? I told you that Y is something which we are keeping reserved for the label of the class. So I'm using the names of the axes as X1, X2. Can you repeat now question based on this understanding? So X1 and X2, whether to be bound on x-axis or y-axis. Okay. So I'm exactly not getting what it means by bound. You mean to say that it has to be lying on the x-axis? It is not compulsory. It is all the data that decides the clear separation. I could have also taken some boundary like this. I mean, which is not falling even on x-axis, right? Equations are confusing, Radhakrishna. Suppose we had decided as humans that this line is not so good. I'm taking another line which separates the two classes by passing parallel to x1 axis, right? So then I could have taken the slope differently. So what would be the line then? Then y equals 2 could be the equation of the line, because then the slope would be 0. Consider class 1 and class 2 with the same set of coordinates. Yeah. So suppose what I am getting from your question is, suppose all these points were lying very close. Is it the question, Radhakrishna? If these 6 points are lying very close to each other, maybe they are superimposing. That means now we need to redefine the features which we selected, the features x1 and x2, so that these points can be arranged in such a way that they separate a little. They cannot be superimposing, otherwise even non-linear boundaries would be the difficulty, right? So, yeah, okay. So Radhakrishna, is it clear? Yeah, derive the equation based on, no, sorry. Then in that case, I should not be using y2. You don't need to use y if you are reserving this label for classes. So I should be saying that it is x2 equals 4. Yeah. Is this all right? Yeah. So then y is not used in the equation because I want to say that I am taking x and y as the input-output pair of observations in my training, and y is representing the class label. So because y is representing the class label, whether it is the blue star and red circle, these are the two labels, or it could have a value 0 and 1 representing those. So x is basically a feature vector where it is x1, x2. So because I am representing the input data by two feature vectors, two values, then it is taken as x1 and x2, and that is why we are not taking y in this description. Okay. So class 2 was it 2, 2, 2, 3, 3, 2. Suppose we try to draw this, right? 2, 2, 2, 3. So 2, 2 is this. Okay. So let me take a bigger marker. I take a different color, maybe blue color, and a different marker. So 2, 2, 2, 3. 2, 2 is lying here. Okay. And 2, 3 is lying here. Okay, maybe some approximate point, and 3, 2. 3, 2 is lying here, right? So can you draw a linear boundary. Maybe this star was not there, and there were 3 points. What he's suggesting, 2, 2, 2, 3, 3, 2. Okay. So would you be able to draw a line against these points to separate them out? We cannot. So had this been the case when it had the class 2 as the one which you are suggesting, then it was very difficult for us to draw a line to separate the two classes. And then we would actually go for non-linear boundaries. If only if the classes are, the samples are linearly separable, then only we go for a linear boundary. Is it okay? Fine. Any other doubt? So equation x2 equal minus x1 plus 1. This is not the right equation in the scenario where I had taken these points. The reason, as I explained to you, is that if I take 1 as the intercept, it will not be able to separate out the samples belonging to two different classes. I am trying to draw this line. So this line which I have mentioned here, x2 equals minus x1 plus 1. If I draw this, 1 means it is this intercept, right? So let me take a little broader line. If suppose I take 1 as an intercept, this could have been this blue line, and this one is not the right equation to separate the two classes, even though it is parallel to the one which is drawn already. Okay. Okay. So whose question was this? X2 equals minus x1 plus 1, Harish. So this is not the right equation. So what will be the right equation? It is x2 equals minus x1 plus 4. Okay. Yeah, had it been a non-linear boundary, then we would have required one more feature. So Anish has rightly pointed out that if you have three-dimensional data, then in three-dimensional space, this could be separated. But sometimes it is not possible for us to recreate the third feature. Then we have to go for finding out the parameters of the nonlinear boundary. Right? How to identify which are significant feature vector. So this is a problem which is very serious in machine learning researchers domain. How to select features which are very significant. This is a very important question, and this is one research problem which has been attempted by thousands of researchers across the world even today. This problem is known as feature selection, right? Which features out of thousands which are describing each object, which features are going to be the most discriminative and informative? This problem itself is a very complicated problem, and research is going on. We will talk about some of these things in some future classes, right? The best criteria is that we keep experimenting with some features, and the ones which are giving us the best accuracies, or let us say minimum error, we try to select those features. This itself is a optimization problem, right? Biswajit, is it okay? So, which are the other questions? Given the two classes, how do you draw the line? Yeah, I told you that so far I have not made my machine learn. So far I am using human intelligence to draw this line. To tell you how later the machine learning classifier would use this boundary to classify the test samples, and later we will study several algorithms which automatically find the parameters of the decision boundary. Okay? Is it okay? So x1 is the x-axis in usual term. Okay? So x2 equals minus x1 plus 3. That may separate. You can try it on a graph paper and then try whether these points are separated. Of course, the points will not be as big as the ones which I have drawn. So maybe you are able to draw a line that separates the two sets of samples, right? Okay, so plus 3 equation would also be possible. Okay. Yeah, so there is a class at 4, so I will have to stop here. So what is minus x1? Minus 1 is actually the slope of the line, and x1 is nothing but the one which we used in y equals mx plus c. So that is it, its first dimensional feature. Okay. So how did we arrive at the intercept 4? Yes, this is only visually seen. Based on the data, we are visually trying to identify some points through which we can pass a line, and that will be the decision boundary. And I told you that here we are using human intelligence to see the samples. Now we will have to ensure that our system is capable to understand the data and formulate such lines. Yeah, looking at the samples, definitely, right? So I'm closing it here, and then we will meet in the next class to discuss more. Okay, so I'm taking this last question from Yashasvi. Both slope and intercept are found based on the figure. So will the diagrams be drawn to scale in exams as well? No. So don't worry about the exams. We will talk about it later on. Okay. So tomorrow's class, you please have an eye at the schedule. If they schedule your class, then it will be there. And if they schedule and I am not in a position to take, then I announce it over the portal, right? So I'm not sure about tomorrow's class. You can have a eye on the schedule, right? So I'm stopping it here. Have a nice day.